In this lecture we talk about covering space of S1 wedged with S1, and this is given on page 58 of Hatchet. So these are the diagrams you will find on page 58 of Hatchet about covering space of S1 wedged with S1. So we want to redraw this figure so that it does look like covering space of S1 wedged with S1. So this is S1 wedged with S1. So say this is generator A and this is generator B. So this covering space we are redrawing here. So this is the base point here. So this is our base point, and this base point comes right here, and this other point, this is here. So first generator, so we go around and come back to our base point, and that gives us A. But we could have gone twice, so we would have A square. We could have gone 3 times, we could have A cubed, and so on. So all these are paths which can be obtained by going around here on this portion of S1. So but all of them are generated by A. So these are the generators. So second thing is we can go around B. So we go up and go back down. So this will give us B square. So you get B square. And the third thing is that you have the third generator is BA B inverse. So again you go B, then you go A, and then you come back the same path. So you have BA B inverse. So you have BA B inverse. So notice that we are going in paths. So we are going from here B, then we are doing A, and then we are coming back the same thing to get B inverse. If you're algebraic person, then you can actually do the opposite. You can start from here, but it is the same story. So you can go here, you can say B inverse, then A, and then B. So you can start from here, B inverse, then A, then B. So B inverse, A, and B. So these two figures are the same. So we write this as the generator here because obviously you can have another path which is B, you go A, and then you go B. So BAB is another path, and this is just generated from BAB inverse, and then you apply B square to it, you get BAB. So these are the generators of this cover S1 wedged with S1. So B is in blue, and you can see A is in yellow. So these two figures are the same, but I have redrawn it because to me this is more conceptually clear that this is a cover of S1 wedged with S1. So now another figure, this is figure number 2 on Hatchet. So this is a figure, and the corresponding, this is a covering space of S1 wedge S1. So to show it as a covering space, we redraw it like this. So B is on this side and A is on this side, because A covers this side and B covers this side. So these are the same figure, they're just redrawn. So again you can go from here A and come back, you have A square. So notice that A itself is not a generator because the base point is right here. So this is the base point right here. So this is the right here. So we have to come back to it. So you have A square. So A itself cannot be the generator. Similarly, you can go via B and come back, you get B square. And then you can go via A and then come back here via B. So A and then B, you get AB. So again, if you are algebraist, you can think going B and A. Then you can say you're going B first and then A first. So it depends what point of view you are considering, but in any case it is the same, because the paths we compose from left to right, but in algebra we go from right to left. So these three are the generators. Obviously there are large number of other paths also. You can just keep going in this loop again and again. So you can have A square, A4, A6, and so on. So all these are generated by A square. So obviously A itself is not a generator because this is the base point, and we have to come back to it. So if you just take A, you do not reach the base point. You reach the top point, but that is not the base point, so you have to come back. So in Hatchet it is very clear to just draw one point, which is the base point. So now this is figure number 3 of Hatchet. This is the base point, and this base point is right here. So these two are the figures. So first you can see B covers this part, This blue part covers blue circle and yellow part covers yellow circle. So these two figures are precisely the same. Here I have redrawn it just for clarity. So again, how do you get a square? You go from the base point A and then you come back. So you cover this part. So you get a and a, you get a square. For b square, again you go b and come back, you get b square. So you have a square, you have b square. Then a, b, a inverse. So you have a. In the loop it doesn't matter, you know, because once you're here you can decide whether you want to go this direction or this direction. So this arrow doesn't really matter in a loop. So you have a, then you have b, and then you come back the same path to have a, b, a inverse. So this is how you get a, b, a inverse. Obviously you can also write a new path, which is you go a, b, a. So you go a, then you go b, and then you come back a. But inverses are important as generators, because now you can see ABA is just generated by ABA inverse times A square, which will give you ABA. So this path is generated by these two. Third generator, BAB inverse. So same story. You go B, you go A, and then you come back on this. So you get B inverse. So BA, B inverse. So now example number 4, this base point here is now here. So we have to start here and come back here. So these two figures are precisely the same. And now we are understanding these generators. So A, you come back here, you get A. Obviously you will also get A square if you go around this path twice or 3 times or 4 times. But A square, A cube, everything else is generated just by A. So this is a generator. Then b square standard, you go up and then you come back to the base point, you get b square. Then b a square, b inverse. So you have b and then you go this a square and then you go b inverse. So that is this generator. Obviously you could have also gone like this. You could have gone b a b. So you could have gone b a, then a back again, a square, and then if you gone here like this, then you would have b. So this is another path, but as you can see, this path is just generated from here, b a square, b inverse, and then b square. This will give you b a square b. So again, inverses are important in generators. That's why you always include inverses. And finally you have b a inverse, b inverse. So let us see this. So you have b and then you have a, then you have b again, you come back, then you have a inverse, you come back this way, so a inverse, and then you have b inverse. You trace the same path back again, you have b inverse. So that is this path. So yeah, so if going path is like this, if you try to come back here this way, then you have b inverse. Otherwise you take the other route. So now this is example 5. Again, these two are the same figures. So now again, this blue part covers this blue part, this yellow part covers the yellow part. So the base point here is same as this base point. So this is our base point. So you have to come back to this. So again, Hatchet is very clear. They just draw one base point. So here we are covering it. So we have drawn 3 of them. So first path is you go A, come back, come back, come back to your base point, you get a cube. Similarly with b, you go b, come back, you get b cube. Then a, b inverse, so you go a and then you go this way, b inverse, and then b inverse of a. So here you go b inverse and then you come back a right here. So you get b inverse of a. So that is it. These are the generators.